Have you ever wondered why some Power BI reports are quick and efficient and get you answers right when you need them, and why other ones seem to be going in just a crawl? Now, it's likely that the problems are not with your DAX formulas and they're not with any of your visualizations, but they have to do with what's happening in the back end, right? What's happening in your data model. The data model plays a big role in the performance of your report as a whole. And what's crucial for that performance is to know what kind of schema you have and to make sure that you're using the appropriate schema type. Okay? So here, can you tell me this? Does your data model, when you look at it, look more like what's pictured on the right or what's pictured on the left? On the right, you can see that there's multiple branches between our fact tables to our dimensions, which are date, year, quarter, customer, city, produce type, location, and store numbers. While on the left, there is only one relationship between each fact and dimension, just one. Now, you can imagine that having multiple relationships to define is giving multiple instructions to the software, and having one has it way more clearly defined. Now, Power BI thinks the same way, okay? Power BI prefers a star schema. Can you see the star? Opposed to a snowflake where we have these branching out of the tables. So then you might be thinking, what do I do now if what I have in my model more closely looks like what's on the right, snowflake, versus what's on the left, which is a star? Well, right off the bat, we're going to collapse those three tables down into one. Because the branching is unnecessary, because we know that these branches actually have an implied relationship between them when they're flattened into a more tabular format. For example, in a calendar, when you look at a calendar, you know that the week has a relationship to the date, has a relationship to the quarter. You don't really need to break it out into its parts to understand it. So by doing that with Power BI, by breaking it apart and having those relationships, you're basically giving it instructions with each of these lines, instruction, 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 when all you could have to do really was give it one set of instructions, right? This is how you treat the whole calendar versus this is how you treat a date, how you treat a year, how you treat a quarter. So that's what you want to keep in mind when you're creating those relationships and creating those tables. So let's go ahead and flatten them. Let's flatten the date, the year, and the quarter. Customer, city also has implied relationship to each other. So that can be collapsed down. So produce and produce type have a relationship, right? You don't need to have the produce separated from the kind of produce that it is, separated from its barcode or any other identifying details. Okay, locations and store number, we can flatten that as well. And once we flatten those, so then instead of having these 8 tables, we instead have just a set of 4 to 5. You're going to see the performance improve exponentially as a result. It will also make it so that your time intelligence functions and more complex DAX functions work a lot more efficiently. All without you actually ever having to touch those formulas, and your formulas in DAX will actually be able to be smaller because you're not having to direct it between all of these different tables. This is what to use when and where. You don't have to do all that because Power BI knows what to do with that implied relationship that you've established when you collapse them down. And as a result, you get a more performant table. And your DAX will be more performant as well. Now, DAX is its own thing altogether, and we could deep dive into DAX and how to improve it maybe another day. But for now, let's just focus on how to make a star schema. So now, when you go back to create your data model or to update your data model, remember, it prefers a star schema with one clearly defined relationship between the facts and the dimensions. You do not want branching relationships between your facts and dimensions like you might see in other software. So I hope that helped. Thanks so much.